Okay, so we're going to look at sine and tangent today. Sine is so super related to cosine, it should be easy. So if we have the sine of 105 degrees, okay, this is the sine of what plus the sine of what? 60 plus 45, which gives us the sine of 60 cosine of 45 plus cosine of 60 sine of 45. That follows your note card. Sine, cosine, cosine, sine. So the sine of 60 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. Sine of 45 is square root of 2 over 2. So you get square root of 6 plus square root of 2 all over 4. Nope. Plus is plus when you're dealing with sines. Okay? Which is opposite of the cosine. Okay? So you just follow your note card. So what if you have one with, What if you have one with like radians in it, like the sine of pi over 12? What makes pi over 12? The sine of 4 pi over 12 minus 3 pi over 12, which is the sine of 3 or pi over 3 minus pi over 4. So it is the sine of pi over 3 cosine of pi over 4 minus cosine of pi over 3 sine of pi over 4. Sine, cosine, cosine, sine. All right, so sine of pi over 3, square root of 3 over 2, cosine of pi over 4, square root of 2 over 2, minus cosine of pi over 3, 1/2, sine of pi over 4, square root of 2 over 2. So it's the square root of 6 minus square root of 2 all over 4. All right, so sines are a lot like the cosine stuff. Okay, kind of get the same answers, type of answers. The tangents are a little different. Now, here's the big warning. Try to use 60 degrees, which is pi over 3, and 120 degrees, which is 2 pi over 3, instead of 30 degrees, which is pi over 6, and 150 degrees, which is 5 pi over 6. Because you get a lot less complicated fractions. Because what is the tangent of 60 degrees equal to? Well, looking on your unit circle, the sine of 60 degrees is square root of 3 over 2. The cosine of 60 degrees is 1/2. So if we multiply both the top and bottom by 2, it's just a square root of 3, right? What's the tangent of 30 degrees? Well, that's 1/2 over the square root of 3 over 2. Because the sine of 30 is 1/2. Then the cosine of 30 is square root of 3 over 2. So if we multiply by 2 on the top and bottom here, we get 1 over square root of 3. Can't leave square root of 3 on the bottom. So you get the square root of 3 over 3. What looks easier to deal with, that or that, especially in fraction situations? This one does. Because what this one will do is give us a complex fraction. So if you can, try to use 60 degrees. What do I mean about that? Well, let's say you have the tangent of 75. Now, what two numbers would make 75? Well, you just instantly say, well, 30 and 45 make 75. Well, if you use 30 and 45, what you're going to do is get a complex fraction. Now, I'm going to do it with 30 degrees right now the first time. And I'm going to show you how ugly it gets. So this is the tangent of 30 plus 45, which equals the tangent of 30 plus the tangent of 45 over 1 minus the tangent of 30, tangent of 45. Well, what's the tangent of 30? Well, we said it was square root of 3 over 3. Tangent of 45 is 1 over 1 minus square root of 3 over 3 times 1. See how complicated those fractions are? Now, is there another way to get 70? And then we'd keep going on this, but I'm not going to keep going because there's a lot to it. Okay? Is there another way to get to 75 without using 30 and 45? Can't use 15. 15 is not on your unit circle. 120 minus 45. 120 minus 45. There you go, Ethan Brown. We want to use 120s or 60s instead of 30s or 45s. So we're going to do this. So it's the tangent of 120 minus the tangent of 45 over 1 plus the tangent of 120, tangent of 45. Tangent of 120 is negative square root of 3. Okay, because we're in the second quadrant and it's the same as 60. Minus 1 over 1 minus square root of 3 times 1. So you get negative square root of 3 minus 1 over 1 minus square root of 3. Oh no, we have a square root in the denominator. What am I to do? Multiply by the conjugate of the denominator. Conjugate of the denominator is 1 plus the square root of 3. So we get negative square root of 3. Outers is minus 3. Inners is minus 1. Last times last is minus square root of 3. Denominator, 1 times 1 is 1. Outers and inners and conjugates always cancel. Minus 3. So your numerator is negative 2 square root of 3 minus 4. Your denominator is negative 2. If you factor out a negative 2 on the top, and cancel it with the negative 2 on the bottom, you get square root of 3 plus 2. Which, if you would have done this problem all the way out, you would have gotten there eventually. But it's a little easier like that. This is the quickest way. Tangents are a little more ugly than sines and cosines. So let's do the tangent of negative 5 pi over 12. Oh no. How do we do that? What minus what is negative 5 pi over 12? Now, if we can, we want to use something like 2 pi over 3, okay, or pi over 3, and subtract to get negative 5 pi over 12. All right, so what is 2 pi over 3? How many over 12 is that? 8 pi over 12. So, if I take 3 pi over 12 minus 8 pi over 12, I get a negative 5 pi over 12, right? Well, what's 3 pi over 12? Pi over 4, right? 8 pi over 12, 2 pi over 3. So it's the tangent of pi over 4 minus the tangent of 2 pi over 3 over 1 plus tangent of pi over 4, tangent of 2 pi over 3. Tangent of pi over 4 is 1. Tangent of 2 pi over 3 is negative square root of 3. Well, if we have minus a negative is plus a positive over 1 plus 1 times negative square root of 3. Well, at this point, I can't leave the square root of 3 on the bottom, so I have to multiply by the conjugate of the denominator, which is 1 plus the square root of 3. 1 times 1 is 1. Outers is square root of 3. Inners is square root of 3. Last times last is 3. Denominator 1. Outers and inners cancel. Minus 3. So we get 4 plus 2 square root of 3 over negative 2. So if I factor out a negative 2, I'm going to get negative 2 minus square root of 3. If I cancel negative 2's, I have negative 2 minus square root of 3. Okay, all right. So I want you to work on problems on page 185, numbers 9 through, let's go 9 through 15 all. So that's 7 problems for tomorrow. The signs will be really easy and quick. The tangents won't be quite so quick.
Most of like the tangents just gonna be looking like some form of 2 and a square root of 3.
Mm-hmm.
That is absolutely crazy.